Hello everyone, welcome to a new session of your maths class. Today we will learn the third part of our chapter number 9, Algebraic Identities and Algebraic Expressions and Identities. In the last classes we were discussing how to multiply a polynomial or some group of polynomials. Initially we learned that step by step. First we multiplied a monomial by a monomial, then a monomial by a binomial. Now we are going to learn how to multiply with complex numbers, means numbers of more than two terms or more than one term. The first step, or in general we can say the multiplication of a polynomial by another polynomial. For that we will learn in two ways or two parts. First we will learn how to multiply a binomial by a binomial. Then we will see how to multiply a binomial and a trinomial. Let's see to that. The process of multiplying a binomial by another binomial is similar to the process that we learned when we try to multiply a monomial and a binomial. It will be very easy. Let's see this process with the help of our exercise question 9.4, question number 1. The question says to multiply two terms. This is an expression. This is another expression. This is clearly a binomial. What's the definition of a binomial? A binomial is a polynomial having two terms. So we have two terms, 2x plus 5, and the second expression is 4x minus 3. We need to multiply these two. Let's see how this can be done. So I'll write the answer over here. First step is to write the numbers 2x plus 5 into 4x minus 3. So we have two terms with us. Let's try to multiply. To multiply these two terms, first take the first element in the first bracket. Who is that? 2x. So we can write here 2x. Take the term and multiply the second bracket completely. What's the second bracket? It is 4x minus 3. Then whatever symbol be in between the first two terms of the first bracket, put that one over here along with the number. Who is that? 5. So take the number 5 and multiply the second bracket completely. Who is the second bracket? 4x minus 3 again. So I repeat the steps. First element of the first bracket into second bracket completely. Then plus second element in the first bracket into second bracket completely. And if you simplify it, you will get the final answer or the required answer. So this is 4x into 2x into 4x. First multiply the numerical part, it is 8. Then x into x, that is x square. Then take the number and multiply. This is simply what? This is the process of multiplying a monomial by a binomial, which we had just learned now. So 2x into minus 3 is minus 6x. That's the end of the first part. Then plus 5 into 4x is 20x. Then minus 5 into 3 is minus 15. Now we have two like terms here. We can simplify them as 8x square. Then minus 6x plus 20x is plus 14x minus 15, which will be our required answer. Now let's see the second question in our exercise. Now the second one, it is the fourth one. A plus 3b into x plus 5. So let's try. Do the second and third one by yourself. It is very easy. Just follow the very same method. Let's see the fourth one. This one is also not different from the one that we have just done. Take the first element of the first bracket. It's a into second bracket completely. X plus 5. Then second element of the first bracket. 3b into second bracket completely. X plus 5. So a into x. What is a into x? It is ax plus a into 5 is 5a. Here we have 3b into x, which is 3bx plus 3b into 5 is 3 into 5, which is 15. Then 15, and who will be there? 15, b will be there. Do we have any like terms? No, we does not have any like terms. So we can conclude the answer like this only. Then we'll go for the fifth one. It's a bit complicated. It seems to be a bit complicated, but it's nothing. It's a simple question. The question is multiply 2p cube plus 3q square and 3pq minus 2q square. The method that we have just adopted, take the first element of the first bracket, multiply it completely using the second bracket. So we'll make the first element of the first bracket, which is 2pq into the second term is, or the second bracket is 3pq minus 2q square. Then we have the 3q square here. I'll write 3q square including the symbol into what's here, the second bracket 3pq minus 2q square. Now simplification is left. 2 into 3, it is 6. Then pq into pq, p into p is p square, q into q is q square. Then we have a negative symbol, we put that. 2 into 2 is 4. Then p into q, pq into q square. We have only one p, so I wrote there. Q into q square is qq. I hope you understood. 2pq into minus 2q square is what we did. 2 into 2 is 4. P, we don't have another p, so we write p raised to 1 or simply p. Then we have a q here, a q square here. Q into q square is qq. Then plus 3q square into 3pq. 3 into 3 is 9. Then we have one p there. So we will get q square into q is qq. Then 3q square into 2q square is left. So we write 3 into 2. First we should multiply the numerical part. There is a negative symbol and here is a positive symbol. So it will be a negative result. 3q square, 3 into 2 is 6. Now go for the literal part. Q square into q square is q raised to 4. Now is there any like terms? Of course there are like terms. This and this are like terms. We can simplify. Minus 4 times pq cube plus 9 times pq cube will give us. So I'm writing the final answer. No change for this one or this one here. So it will be 6p square q square, then minus 4pq cube plus 9pq cube, which will be plus 5pq cube. Suppose this to be a single term, then minus 4 times the thing plus 9 times the thing will be plus 5pq cube minus 6q raised to 4. So this is the final answer. Just write, it's a basic question, not so difficult. 6p square q square plus 5pq cube minus 6q raised to 4. I hope you understood this one. Now let's move to the last question of this exercise. It's a long one, but it's not that difficult. In this question, I will make a slight rearrangement because for simplified format, I will multiply this 4 throughout the bracket. Throughout the bracket. So let's see how this will come. Okay, let's try. So the question is 3 by 4 a square plus 3b square into. I'm going to multiply this 4 inside the bracket. So this will be 4 into a square. That is 4a square minus 4 into 2 by 3b square will be 8 by 3b square. Why? Because 4 into 2 will be 8. Now the same old process. Take the first number. This first number 3 by 4 a square. Multiply it through the bracket 4a square minus 8 by 3 b square. Then take the next term. Who is it? 3b square. Multiply it through the second bracket 4a square minus 8 by 3 b square. Let's follow our simplification. Let's try. Multiply the first term, or this is the process of multiplying a monomial by a binomial. So we'll simplify very slowly. 3 by 4a square into first term is 4a square. Then we have a negative symbol. Take this number 3 by 4a square and multiply with the second number. Who is that? 8 by 3 b square. So that will end the this much portion. Then take the next term plus 3b square plus. Now we are doing this one. 3b square into 4a square. Then we have a negative symbol. 3b square into 3b square into 8 by 3 b square. Now this will be more easy if you cut more terms. Let me erase this one so that the whole of the screen. Now we can cancel this 4 and this 4 because it's multiplied together these two terms, and we have the same number on the numerator as well as denominator. We can cancel these 3 and 3. Now this 4 and 8 can be cancelled using 4. Here it will be 1 and here it will be 2. Then what about here? Yes, here also we have small terms to be cancelled. 3 and 3 can be cancelled. So let's write the remaining summarized. We have a 3 in the numerator and a square into a square, that will be a raised to 4. Then going to the next term, we have an a square here, we have a b square here, and we have a 2 here. So it will be 2a square b square plus 3b square into 4a square. 3 into 4 is 12. So that is 12a square b square. And we have 8. We have a negative symbol, so that will be a b square, and an 8, that is 8b raised to 4. Why b square and b square is b raised to 4. So we can simplify them as by, we have two like terms here, minus 2a square b square plus 12a square b square. So that's it, 3a raised to 4. No changes for that, but we do have a change here. This will be minus 2 times a square b square plus 12 times a square b square will give us 10 times a square b square, and the last term will be negative of 8 minus 8b raised to 4. That will be our final answer. Now let's see how a binomial can be multiplied with a trinomial, and after that we will follow how to multiply. Here first we will multiply. This is a binomial and a trinomial. First we will do this process. Then after that we will multiply this trinomial with another trinomial. Let's see. And we have a last question as well from this exercise. Let's do all three of them. First we will go for the sixth one of exercise 9.4, question number 3. The sixth one. The question is to find the product of x plus y into, so let's write x plus y into x square minus xy plus y square. So let's write, what was the technique used for multiplying a binomial and another binomial? Use the very same concept. So what happens? First term of the first bracket, x multiplied throughout the second bracket. Who is the second bracket? X square minus xy plus y square. Then the second term of the first bracket is y into the term is x square minus xy plus y square. Now it's all about simplification as you have been doing. X into x is x cube minus y, there is a negative symbol. Then go for the next term, x into xy is x square y. Then we have a plus symbol, x into y square is xy square. Now plus y into x square. It's better to write in alphabetical order so that we will understand whether that is a like term. So here is y into x square. It is actually yx square, but this is same as x square y because 1 into 2 and 2 into 1 both are same, isn't it? Same way y into x square is same as x square and y, and always try to write in the alphabetical order. So x is coming before y, so I will write y into x square as x square y minus y into xy. That will be, we have a negative symbol here, that will be xy square. Then we have plus y and another plus y, so this will be y cube. Let's arrange them, and if there is anybody to be cancelled, let's cancel them. We have minus x square y. We have minus x square y and plus x square y, so we can cancel these two. Then we have xy square and x minus xy square, so this can be cancelled as well. So we will remain, this will be x cube plus y cube. Since the symbol of y is positive, we can write them as x plus y cube. Now let's do the 8th question of this exercise, or this question number 3 of this exercise. The question is to multiply a plus b plus c into a plus b minus c. So we write a plus b plus c into a plus b minus c. How will you write? The same process, but an additional number or an additional term will be there. So let's write, we will begin from here. First term of the first bracket, that is a into second bracket completely, a plus b minus c. Then the second term, so we have done with this one. Now let's take the second term, plus b into a plus b minus c. Then the third term is plus c into the second bracket completely, a plus b minus c. Now let's try to simplify this. A into a is a square, then plus a into b is ab, then a into c, but we have a negative symbol here, so I will write minus ac, then plus b into a, it is ba, but how will we write? We will write it as ab, plus b into b is b square, and we have b and minus c, that will be minus bc. Then c into a, it is ca, but we will write it as ac. We follow the alphabetic order. Then c into b is plus bc. c into minus c is minus c square. Now check whether there are any large terms. Before that, write the terms with highest power. We have a square, we have b square, we have minus c square. So first write three of them: a square plus b square minus c square. Now we have, check whether we have any like terms. We have an AB, then another AB, okay, nobody else, so we will write 2AB. Now we have a minus AC here and we have a minus AC here, so we have plus AC here, so we will cancel these two. So what? No need to write any of them. Then go for the next terms. Yes, we have a negative BC and a positive BC, so we can cancel them as well. So the final answer will look like a square plus b square minus c square plus 2ab. Now let's see the fourth question of this exercise. It seems to be a bit long, but it's simple. It's a combination of whatever things we have learned from this session. A plus b into c minus d. So let's write the answer. First we need to multiply a plus b and c minus d. Then a minus b into c plus d plus 2 into ac plus bd. So let's see how this will be coming. This is the product multiplication of a binomial by another binomial, which we have already done. So let's write the answer. A into c minus d. I hope I don't need to explain anymore. First term into second bracket completely plus second term of the first bracket into second bracket completely. Then this much is the product of these terms. Now we have plus a. First term is a into second bracket completely c plus d minus b into second bracket completely c plus d. So this will end this much. Then we have a small term 2 to be multiplied with the terms AC and BD inside bracket. So let's write 2AC plus 2BD. Then now let's simplify the remaining terms. Inside the bracket, who will be remaining? A into C, AC minus A. How this is A into C is AC minus A into D is minus AD plus B into C is BC. Then B into D is minus BD plus A into C is AC plus. Why I have removed this bracket? Because there is no negative symbols over here, that's why I have removed. But if there is a negative symbol, we cannot remove this easily. There will be questions like that. Let's see. Then A into C is AC. We have done this. Now A into D is AD. Then who is remaining? We have a minus B outside the bracket of C plus D. So this will be minus BC. Then B into D is minus BD. Then we have the last two terms 2AC plus 2BD. Now all we need to do is to check whether there is any like terms. If so, we can cancel them or write them together. We have an AC here, another AC here, and 2 AC here. So how many AC? 1 AC plus 1 AC plus 2 AC. How many AC? 4 AC. We have 4 AC. So we have whatever terms we have written, put an underline over it. Otherwise, we won't recognize whether it has. We still will have a doubt whether we have written this term or not. So, to avoid that, put a denotation to represent that the term is already taken. Then we have a BC here. We have a plus BC. We have a minus BC. So nobody will be there. Then let's see about AD. We have minus AD here. We have a plus AD here. So we can cancel them as well. Now who is remaining? We have a minus BD, minus BD. So minus 2BD. So we'll write minus 2BD. But now we can see that only one term is remaining without any symbol. We have not cancelled. Neither we have put a line on the bottom. So we'll write that term. So 2BD. Now see the interesting thing. This is minus 2BD. This is plus 2BD. This can be cancelled. So what will be the final answer for AC? So after simplifying all of them, the only answer that we got is for AC. I hope you got this one. Let us move on to the next part. We need to learn next identity. Identity can be defined as any mathematical equation that is true for all the variables in it. Or if you put any variable in a mathematical equation that will be true, then we can call that particular equation as identity. For example, I'll say with a simple example, if you want to add maybe 15 plus 3 and 15 plus 3. Actually, this is actually 18 into 18. We can split them as 15 plus 3 or anyways 10 plus 8 or 12 plus 6. Anyway, I'm just giving you an example to demonstrate what is the value of identity or what is the importance of identity. So, if you want to multiply these two terms, which method will you adopt? We can use the multiplication of a binomial by another binomial, isn't it? Now, that is one way. Let's consider this 15 as a term A. Yes, let's see this as A and this 3 as B. Then, if that is the case, then we need to find the product of A plus B and A plus B, isn't it? To find this, the general method that we have been using can be adopted. What is it? The multiplication of a binomial by another binomial. So, what is the process? Taking the first term and multiplying the second bracket A plus B. Then taking the second term of the first bracket, multiply the second bracket completely. A into A is A square plus A into B is AB plus B into A is AB. Then B into B is A square. So you will get get it as A square plus 2AB. AB plus AB is 2AB plus B square. So this is actually A plus B into A plus B. So whenever you find any number to be multiplied as A plus B into A plus B, you can substitute this formula. That is, this is same as A plus B. What is A plus B into A plus B? What is X into X? X into X is X square, isn't it? The same way A plus B into A plus B is A plus B the whole square. So we learn a new identity. A plus B whole square is equal to A square plus 2AB plus B square. Now coming to our part, 15 plus 3 into 15 plus 3. So here 15 is A, B is 3. What do we need to do? We just need to put here. 15, A means 15. So 15 square plus 2 into A into B. 2 into A is 15 into B is 3 plus B square. B is 3. We know 15 square is 225 plus 2 into 15 is 30. 30 plus 3 is, 30 into 3 is 90 plus 3 square is 9. So we can do this one together. 225 plus 9 is 234. 234 plus 90 is 324. Now I have took a not so easy number, that's why it's coming like this. We will see few less difficult numbers in future, but what we need to concentrate now is that this identity is called as the first identity. So whenever you see a term to be multiplied like this, for example, let's see one easy exercise. If you are asked to find what is the square of 15, what is the square of 15? We know 15 square is 225, isn't it? Let's see this answer using the identity that we have learned. If we are able to make this as something plus something whole square, or some a plus b the whole square, then we can apply this identity. That is the beauty. So 15 can be written as 10 plus 5, isn't it? So square means 10 plus 5 whole square. We know. So this is what we need to find. We know a plus b the whole square is same as a square plus 2ab plus b square. What does this simply mean? Sum of two terms, then its square. Sum of first term plus second term, then squaring it is same as squaring the first term plus 2 times first term into second term plus second number whole square. Let's see. Who is the first number here? It is 10. So 10 square plus 2 into first term into second term is 5 plus b means 5, that is 5 square. What is it? 10 square is 100. It's easy, no? 2 into 10, it is 20. 20 into 5 is 100 plus 5 square is 25. So 100 plus 100 is 200. 200 plus 25 is 225. This is just a small demonstration. We can find any different any number using this identity. So this is the first identity that we need to learn now. I'll write it again. The identity. Please remember the identity. And we have seen how the identity is proved. The first identity says a plus b the whole square, or you can write identity number 1. A plus b the whole square is equal to a square plus 2ab plus b square. Now let's see the second identity. Second identity says a minus b the whole square. What is a minus b? Let's prove here. A minus b whole square means a minus b into a minus b, isn't it? So let's do this one. Take the first bracket, first number, second bracket completely a minus b. Then we have a minus b here. Then a minus b, second bracket completely. So this is a into a square. A into minus b is minus ab. Then minus b into a is again minus ab. Then minus b into minus b is plus b square, because both the negative terms will become the positive one. So what's it? A square minus ab. How many ab? Minus 2ab plus b square. So here is our second identity. What's it? A square minus 2ab plus b square. Learn these identities by heart. It will be very, very helpful for you. Now the third identity that we need to learn is a plus b into a minus b. Now if some equation may be coming here like this, we will see all the examples, all the questions using these identities in our next class. So everything will be clear. If there is any doubt, any little doubt if remaining, then let's see what is a plus b into a minus b. Same way, take the first number a into second bracket completely a minus b plus second number b into a minus b. A into a is a square minus a into b is minus ab plus b into a is ab. Then b into minus b square. We have minus ab plus ab. We can cancel them. So who will remain? A square minus b square. This is the third identity and the last identity that we need to learn this year, I think. No, we need to learn one more identity. The last identity says the product of, okay, after this we will explain x plus a into x plus b. Let's see what this will be yielding us. First term is x plus a. We need to multiply it using x plus b. Take first the first number x, then into x plus b plus a into x plus b. X into x is x square plus x into b is xb plus x into a is xa plus a into b is ab. Now we can see, we can write x is common in both the terms. So we'll take the x outside, then who will remain here? It is b plus a plus ab. Or you can write this as a plus b, no harm in that one. So we will conclude x plus a into x plus b is same as x square plus x into a plus b plus ab. I know I am moving a bit faster, but it's you can revise the video and watch it again. There will be no problem with that. So if you are having any doubt with any steps, please revise the part that is doubtful for you. Now we have 4 identities. This is the last identity. Okay, this is the final identity that you need to learn in this year. Only 4 identities. In the coming year, you will have to learn some more identities, maybe 10 or 12 of them. So time being, let's get by heart with this one. Otherwise, you won't be able to do well in the next year. The first identity says sum of two numbers whole squared is equal to square of first number plus 2 times first number into second number plus second number square. You can learn like this: a plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. Then a plus b into a minus b is equal to a square minus b square. X plus a into x plus b is equal to x square plus x into a plus b plus ab. All these are very easy to be learned once you by heart it. Now we will apply these identities every now and then in the equation that will be given to us, or in the questions that will be given to us. For examination also, the probability of asking this kind of questions is very high. So be prepared with this one. And the second identity, what the second identity means? Difference of two numbers, and when it's squared, if it's like this, we can substitute it as first number square minus 2 times first number into second number plus second number square. Then third identity means sum of two terms into, or the product of sum of two terms and difference of two terms is same as the difference of its squares. The difference of its squares. You will learn this identity. It's very helpful identity. Then the last term, a number plus something into that same number plus a different number. For example, you can see 10 plus 8 into 10 plus 5. Question can be asked like this. So we can write this as, what is x here? X is 10. So 10 square plus 10 into, what are the terms a and b? It is 8 and 5. That is 8 plus 5 plus ab. The product of the a and b. That is 8 into 5. Let's see this one. So what it will give? This is 100 plus 10 into 8 plus 5 is 13. 13 into 10 is 130 plus 8 into 5 is 40. So you will get the answer. 100 plus 130 is 230. 230 plus 40 is 270. Now to check whether this identity is correct, just go for this one. What is this? 10 plus 8, it is 18 into, what is 10 plus 5? 15. Let's see whether the product of these two numbers is 270. 18 into 15. 5 into 8 is 40, remainder 4. This will be 90. Then 8 into 1 is 8. 1 into 1 is 1. So this is 0. 8 plus 9 is 70. Remainder 1. So 270. See? So this is the helpful part of identity. This could be, you might be wondering, the better way is to multiply these two numbers, right? But it's not the case. You will be having different identities, different big polynomials, and you will be able to factorize. That's a term that you will hear more often in your coming years. So for the time being, just understand these identities, and in the next class we will learn how these identities will be helpful in solving certain problems. So that's all for the day. Thank you, and have a good day. See you all in the next class.